Usual, please make sure that you have attempted these problems before you watch this video, because you will learn a lot more if you do it yourself first. All right, so to set up the integrals to calculate the area bounded by both of these graphs, I want to do a sketch because I need to know where, which function's the upper function, which function's the lower function, and where they intersect. So I have x plus 1, and I have x equals y minus 2 squared minus 1. Now you'll notice that this is a parabola, but it's an x equals y squared parabola. So it is not a parabola facing up or down. This is a graph facing sideways. So I would honestly start plugging in points. Like if you plug in y equals 2, so if you need to make a t-chart, let's say I plug in y equals 2. That would be -1 for x. So I have the point -1, 2. That's where my vertex is. I'm going to plug in y equals 3. So that would be 3 minus 2, which is 1 squared minus 1. X is equal to 0. So the point 0, 3. And then I'm going to plug in y is equal to 4. So if I plug in y is equal to 4, I get 2 squared, which is 4, minus 1, x is equal to 3. So the point 3, 4. And then this is the upper half of my parabola. It's also going to be symmetric. So for example, if you plugged in y is equal to 0, you would expect to get 3. -2 squared is 4. 4 minus 1 is 3. So I have this parabola. So the area between them is going to be this area here. And we're going to use two methods to set up the region, dx and dy. So let's start with dx. So a dx means the width of each representative rectangle is going to be dx, right? Okay, so I have two different areas here. So I've got the area between the upper part of the parabola and then the lower part of the parabola. And I've got those ones until x equals 0. And then after that, I've got the upper part of the parabola and then bounded by the lower function, which is just the line. So let's start by figuring out what the upper part of the parabola is and what the lower part of the parabola is. Now, with a dx, you will also need to make sure that your equation is written in terms of x. You'll notice that my equation is not written in terms of x, it's written in terms of y. So let's go ahead and write it in terms of x. So it's going to be x plus 1 equals y minus 2 squared. Take the square root. When you take the square root, what do you have to do? Plus or minus square root of x plus 1. Add 2 to both sides, and you get y equals plus or minus the square root of x plus 1 plus 2, which makes sense because remember how to graph square roots. This is backwards 1, up 2. You have an upper radical, and you have a lower radical. The upper radical is the positive part, okay? The lower radical is the negative part. Got it? So upper would be larger y numbers. Negative would be the lower y numbers. All right, and then let's go ahead and set up our first integral. So it's going to be the integral from our first point of intersection to 0. So -1 to 0. Our upper function is positive root x plus 1 plus 2 minus our lower function, which is negative root x plus 1 plus 2 dx. And you might think, oh, that all cancels. You can simplify this a little bit if you'd like. It's the integral from -1 to 0 of, and then root x plus 1 minus negative root x plus 1 is 2 root x plus 1. They do not all cancel. But then the plus 2 minus 2, that does cancel. So you just get this. And then you can just use a graphing calculator to solve. Okay, now this next part here, so I've got these. This is bounded by the upper function being the upper part of the parabola, and then the lower function is now the line. So we're going to go from 0 to 3 is where our next point of intersection is. And then my upper function is positive root x plus 1 plus 2 minus, and then the line was y equals x plus 1. Don't forget your dx. Don't forget your large set of parentheses around the whole thing. So that's how you would set it up in terms of x. Now, there's actually an easier way to do this, and that's to set it up. Didn't mean to do that. That's to set it up in terms of y. So if I were to set this up in terms of y, think about this graph sideways, or think of it as like horizontal representative rectangles. So I've got a representative rectangle here, I've got a representative rectangle here, I've got a representative rectangle here, I've got a representative rectangle here. And all of these representative rectangles are bounded by the line and the parabola, because the parabola is already written in terms of y. And the width of each of these representative rectangles is dy. So we can actually just use one integral to represent this area in terms of y. So what you want to look at is your y coordinates of the points of intersection. My first y coordinate is 1, and my last y coordinate is 4. So look at the y coordinates. And then for the quote-unquote upper function minus lower function, your upper function is the one that's to the right. And the reason that it's the one that's to the right is think about where the upper numbers are. So in the x direction, the upper numbers are over here. The lower x numbers are over here. So upper is going to be the right-hand function if you are in terms of y. Okay, so our right-hand function is y equals x plus 1, but it needs to be in terms of y because our width is dy. So if I subtract 1, I get x equals y minus 1. So y minus 1 is my upper function. And then my lower function is the parabola, y minus 2 squared minus 1 dy. So the width of each of these representative rectangles, again, is dy. And the reason you only need one integral is because the whole parabola can be written in terms of y as just this equation. But when we went the other direction, right, when we had these, we had some representative rectangles that were between the parabola and itself here, and then we had some representative rectangles that were between the parabola and the line. But when we went the opposite way, when we did dy's, we were always between the line and the parabola. So we were able to represent it with just one integral. So you need to be comfortable with both methods and just know that you will be tested on both methods. So don't think like, oh, I'll just always do dx because that's the one I'm comfortable with. You have to learn to do this in terms of y as well, and you will be assessed on it.